Hey everyone, and welcome to this Explainer. I am absolutely thrilled to have you here today. We're going to dive straight in because we're going on a seriously fascinating journey, from the absolute basics of matter all the way to some truly advanced nuclear concepts. Whether you're prepping for a big exam or just eager to understand the universe at its most fundamental level, you are definitely in the right place. So, grab your notes, get focused, and let's decode the ultimate building blocks of everything, the atom.
Here's our roadmap for today. First, the ultimate building blocks. Second, elements and compounds. Third, inside the atom. Fourth, why atoms are different. Fifth, top 4 conceptual questions. And finally, a quick revision summary. Let's get to it.
Section 1. The ultimate building blocks. Think about a builder. Let's call him Mr. Tom. If Mr. Tom wants to build a house, what does he need? Bricks, right? The very smallest unit of that entire house is a single brick. It's the fundamental building block. Or think about language. The word dog is made up of 3 distinct letters, D, O, and G. D is totally different from O, and G is different from both. But jam them together and you've got a single recognizable word. Well, in science, the exact same philosophy applies. If you look at a banana, it's actually made up of millions of tiny different units. When we join these tiny units together, we get physical matter. And in science, we call these tiny building blocks atoms.
So here's an absolutely crucial exam-perfect definition for you to remember. An atom is the smallest unit of any matter or substance. Now, they're so unimaginably tiny that they are completely invisible to the naked eye. But make no mistake, absolutely everything we see, touch, or interact with around us is made of these atoms.
Moving on to Section 2, elements and compounds.
So how do these atomic building blocks actually combine? Well, when the exact same types of atoms join together, they form what we call an element. For instance, if you take millions of iron atoms and stick them all together, you get an iron sheet, pure iron. But when completely different atoms combine, they form a compound. A super common real-life example of this is table salt. Table salt is a compound made up of 2 totally different atoms, sodium and chlorine, locking together. The same goes for the sugar you eat, which is carbon, hydrogen, and oxygen, or the water you drink, which is just hydrogen and oxygen chemically combining in a fixed ratio.
All right, Section 3, inside the atom.
Now, just like all of us share a basic human structure, we all have eyes, a nose, a mouth, all atoms share the exact same structural components. I highly recommend writing these down for your exams. Scientists have figured out that an atom is primarily made of 3 subparticles: protons, neutrons, and electrons. The protons and neutrons are locked tightly together right in the center part of the atom, which we call the nucleus. Meanwhile, the electrons are flying around that central nucleus in fixed circular paths known as shells, or energy levels. Now here's a totally mind-blowing fact. A staggering 90% of the space inside an atom is completely empty. Seriously. The nucleus, where all those protons and neutrons are locked away, is incredibly tiny compared to the rest of the atom, but it's super dense. The vast, vast majority of the atom is literally just empty space, and those outer shells where the electrons live. And this brings us to a huge, vital rule in chemistry and physics. Electrons absolutely cannot stay in that empty space. They aren't allowed to just float around aimlessly. No way. They absolutely must rotate on their fixed paths, those shells, almost exactly like how planets strictly revolve around the sun.
Section 4. Why atoms are different.
Okay, so this basically reveals the secret code of the universe. Let's go back to our spelling analogy for a second. Why is the letter D different from the letter O? Well, its shape and structure are different, right? For atoms, their entire identity comes down to a simple numbers game. It's all about the sheer mathematical count of those subparticles. When exactly 6 protons, 6 electrons, and 6 neutrons combine, they form a carbon atom. Always. But if 8 protons, 8 electrons, and 8 neutrons combine, boom, they form an oxygen atom. The numbers literally dictate the atom's unique identity.
Section 5. Top 4 conceptual questions.
Let's test our understanding with question number 1. Are you and I, or human beings, actually made up of atoms? The answer is a massive, definitive yes. We humans store glycogen in our bodies, which is basically made up of sugar, or glucose. And if you were to zoom way, way in on just a single molecule of that glucose, you would find exactly 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So yeah, we are entirely constructed from these basic atomic building blocks.
Moving to question number 2, and this is a really big misconception that bridges biology and chemistry.
Can an atom actually die? The answer is a hard no. Atoms do not die because, well, fundamentally, they were never alive to begin with. They simply make up elements. Think about eating a sweet treat. When you digest that sugar, your living body converts the carbon, hydrogen, and oxygen atoms into other useful substances. But your body absolutely cannot destroy the underlying atoms themselves. They just change their arrangement. They don't die.
Okay, question number 3. Can human beings artificially create an atom?
This one is a yes, and it brilliantly illustrates the raw power of nuclear physics. We actually can create atoms through 2 really intense processes. First up is nuclear fission, which is splitting a massive atom. For instance, inside a nuclear power plant, we can split a large uranium atom into 2 completely new, smaller atoms, barium and krypton. The second process is nuclear fusion, which is combining small atoms. We can take 2 tiny atoms of hydrogen, smash them together with incredible force, and form a heavier atom, like helium. So through these nuclear reactions, we are literally creating new atoms. How cool is that? Which brings us to our final conceptual question. Question 4. If we can create them, can we destroy an atom?
Surprisingly, yes, we can. But it strictly follows the laws of conservation of mass and energy. Relying on Einstein's famous equations, an atom can be destroyed in the sense that its physical mass is completely converted into a totally different form, pure energy. For example, if an atom collides with an antimatter atom, like an electron smashing into a positron and annihilating each other, they leave behind absolutely nothing but high-energy light rays. The physical matter is effectively gone, transformed entirely into energy.
Section 6. Quick Revision Summary. Let's build your ultimate exam cheat sheet to lock this all in. 1. Atoms are the absolute smallest units of matter. 2. When the exact same atoms combine, they form elements, but when different atoms combine, they form compounds. 3. Structurally, protons and neutrons are tightly packed in a tiny, dense nucleus, while electrons orbit in fixed shells, leaving the atom as mostly, 90% in fact, empty space. And finally, 4. What makes carbon totally different from oxygen is simply the specific mathematical number of those subparticles. That is the secret code. Before we wrap up, I want to leave you with this mind-bending thought to ponder. Take a second and look down at your own hands. Since atoms themselves cannot biologically die, and they merely change form or arrangement over time, how incredibly ancient are the indestructible atoms making up your body right at this very moment? Really think about that. Thank you so much for joining me for this explainer. Keep wondering, keep learning, and I'll catch you next time.